Welcome to How to Determine the Number of Significant Figures, or what we also call significant digits. Now it's all about precision, and you want to express a value with precision that you actually measure. And so significant figures really just helps us to determine the digits that were or are really important. And so there's really four major rules here. Okay, the first rule just says that all non-zero digits are significant. Well, of course that's the case. That makes complete sense, right? So if, for example, if we were measuring distance and we said that we had 829 meters and we wanted to count the number of significant figures, well, we just look and we say non-zero digits, 8, 2, and 9 are all significant, and so we have a total of 3 significant digits or significant figures. Now the second rule says that zeros between two significant figures are significant. Okay, well, of course, that is the case again. That makes complete sense. So again, if we were measuring some kind of distance, okay, and we said that we had 809 meters, once again, we would count up the number of significant figures. And we see the 8 and the 9 are non-zero digits. Those are significant. And any zeros between two significant figures are significant as well. So the zero between these two digits is also significant. That means that we have a total of 3 significant figures for this example as well. The third rule says that zeros at the beginning of a number are not significant. So once again, let's think about, in an example where we're measuring distance. Let's say that we measured and we found that we had 0.00700 kilometers. And we were looking at the number of significant figures. Well, one of the things to keep in mind is that we could have actually measured this in meters, but we expressed it in kilometers. And so really 0.00700 kilometers is really the same as 7.00 meters. And if we were to count the number of significant figures in 7.00 meters, okay, we'd actually find that this 7 is a significant digit, as well as these zeros. And we're going to talk about that in rule number 4. So this has a total of 3 significant figures. Well, same way when we're talking about this in terms of kilometers, this 7 is a non-zero digit, it is significant, and these other 2 zeros are actually significant as well. Zeros at the beginning of a number, though, are not significant. And so we end up with a total of 3 significant figures in this example as well. The fourth rule, is zeros at the end of a number, which we could think of are trailing zeros, are only significant if there is a decimal point. So that's why we saw that back here in number 3, this 7.00 meters had 3 significant figures, the 7, the 0, and the 0, because this is a trailing zeros, which are significant because there is a decimal point. Well, if we think about this in terms of the number 10,300 meters, and we said, well, how many significant figures are there? Well, once again, we could count these up, and we could see that we have non-zero digits of 1 and 3. We have a 0 between 2 non-zero digits, which makes it significant. And here we have trailing zeros. But what I want you to notice is that there's no decimal point here. And so these trailing zeros are not significant. And so we actually only have a total of 3 significant figures for this example. Now, if we just changed this and said we had 10,300 and just put a decimal there, well, now we have the 1 and the 3, which are both significant. We have a 0 in between 2 non-zero digits, which makes it significant. And we have trailing zeros that have a decimal point. And because we have this decimal point, now these 2 zeros are also significant as well. So we have a total of 5 significant figures. Lastly, we could have a number such as 10,300.00. Once again, we could count up the number of significant figures where we have a 1 and a 3, both non-zero digits, which are significant. We have a 0, which is between two non-zero digits, makes it significant. We have trailing zeros with a decimal point, and because of this decimal point, once again, all the zeros are now going to be significant as well, all the trailing zeros, which means that we have a total of 7 significant figures. So in these last few examples, we could tell that with first number, 10,300 meters, we could measure with precision on the first 3 digits. In the second one, we could measure with precision for 5 digits. And with the last one, we could measure with precision with 7 digits, depending on how we were measuring these. That concludes how to determine the number of significant figures.